Okay, this is the 2.1 notes. We did this in class, but we are going to go over the ones that we skipped over. They were just equations that we hadn't solved yet. Sorry, let me get off the header and footer. So I need to take my ink, and we're going to work through a couple of these. So the first one that we're going to do is this decimal one that we skipped over in class. Some people try to clear the decimals, some people leave them in. I work with them, they don't bother me. So 0.3 times 3 would be 0.9. 0.3 times 2 would be 0.6x. Bring down the plus 1.2x, and this equals 3.2. These two x's are both on the left side, so we can actually just add them together. So it's be 0.9 plus 1.8x equals 3.2. We want to subtract over the 0.9. So we get 1.8x equals, let's see, if you're doing subtraction with decimals and you don't have your calculator handy, you line them up by the decimal point. You have to borrow. This would be 3 and 2, so 2.3. And then we need to divide by 1.8. So that would be 2.3 over 1.8. We do not turn this into a decimal. We leave it as a fraction, but we do not allow decimals in the fractions. So the way to fix this is move it the number of places that it needs to get rid of the decimal. If you have to move one more than the other, then you have to compensate and do the same thing on the bottom, but these are both one decimal place. So this would be 23 over 18, and that is reduced. We did C in class, so let's look at D. D's kind of a tricky one to make you think it's hard, but it actually has just fractions that are already like terms. So this would be 3 plus 6 is 9 minus 1 is 8. Think of 11 as being over 1, and because it's one fraction on each side, we can cross multiply. So that would be 8 equals 11y. Divide by 11, so we get y equals 8 over 11. And the only thing that would have been a domain restriction here is that your y cannot equal 0 because of the denominators, but we're okay. Y does not equal 0. Okay, let's look at E. This one has us squaring some things, so we have to write it twice and FOIL it out. So this would be x squared plus 5x plus 5x, so that would be plus 10x. Okay, so this is plus 10x, and then we'll have 5 times 5, which is positive 25. Bring down the plus 3. If we distribute this, x times x is x squared. We'll get a negative 2x and another negative 2x from the two different FOILs. So that would be negative 4x. Negative 2 times negative 2 is positive 4. Then we would want to move some things around. I actually think I'll combine like terms first. So x squared plus 10x. 25 plus 3 is 28. That looks a little cleaner. When you go to subtract the x squared, it actually cancels out on both sides. So you're really just left with the 10x plus 28 equals negative 4x plus 4. I would add 4x over, so that makes this 14x plus 28 equals 4. I would subtract 28 from 4, so that would give me negative 24. And when we divide by 14, we get that this is negative 12 divided by 7 when we reduce the fraction down. Okay, for F part, we need to cross multiply because it's one fraction equal to one fraction. So this is 5x plus 2 times 2x plus 3 equals 10x minus 3 times x minus 8. This one I might have to work out a little bit more than in my head. So this is 10x squared plus 15x plus 4x plus 6. This would be 10x squared minus 80x minus 3x plus 24. Combine like terms. Get 19x on the left side and negative 83x on the right side. The 10x squareds are going to cancel again when you try to move them over, so you're just left with the linear parts, which means not x squared. And I would want to add 83 over. So this would be, let's see, 19 plus 83, 102. So 102x, subtract the 6 over, equals 18. So then when we divide by 102, this obviously reduces. 18 divided by 2 is 9. That divided by 2 would be 51. Now we do need to double check because there was an x in the denominators. We need to make sure that those are not the answers that we get for this. It needs to not be a 0 in our denominator. So one of the solutions that doesn't work is 3/10. I just find that by setting this equal to 0. The other solution that doesn't work, if we subtract 3 over and divide by 2, is -3/2. So as long as this is not one of those and we haven't made an arithmetic mistake, everything should be good. But I am going to double check my arithmetic real quick. So we had 19 plus 83, which is the 102, and 24 minus the 6 was 18, and 102 divided by 2 is 51. 18 divided by 2 is 9. So yes, it is 9 over 51. Okay, let's look at G. I think I did this in one class but not in the other, so we'll just work through it. First thing I would do is move this -5 up top. That just makes life easier. To factor the bottom here, this would be 3 and x minus 3. So we definitely need, for our LCD, x minus 3. For the monomials, the 3 and the 6, you just need, if the big one is a multiple of this one, you can just pick the bigger number. So 6. So I'm going to be multiplying every single term in this by 6x minus 3. So there's my fraction for the first one. Plus 6x minus 3. There's my second fraction. It's supposed to be a minus. And equals 6x minus 3 times 5/6. If you've done this correctly, you should get some cancellations. X minus 3, x minus 3. 3 does not cancel 6, but it makes it a 2. So this is 2 times -5, which would be -10. X minus 3, x minus 3, plus 6 times 4 would be 24. The 6's cancel, and then we'll have 5 and x minus 3 come down on the right side. To go ahead and finish and solve this, add your like terms on the left side, distribute on the right side, add the 15 over, and x equals 29 divided by 5. Now double check your LCD. The only thing that x could not be would be 3, because that would make that denominator there 0. Okay, H. H is kind of a tricky one. I would subtract the 5 over first. So that would give you 0. When you go to cross multiply here, you're going to get 0 times everything down here. So you get 0 equals 6. That doesn't even make sense. So this is just no solution. There's no way to solve for this one. Okay, for our next one, factor this to make sure you know what your LCD is going to be, because that's what we use to clear out the fractions. So my LCD is going to be a 2u plus 3, 2u minus 3. If we set those equal to 0, we'll see that we don't want -3/2 as our final solution, or this is going to be the same thing but just positive, or +3/2. So now we multiply everything by the LCD to save space. I'm just going to do it right here. So I'm multiplying each term by the 2u plus 3 and the 2u minus 3. In the first one, the 2u minus 3's cancel, so you're left with a 4 and a 2u plus 3. In the second one, everything in the denominator cancels with everything there, so you're just left with the +10 from the numerator. And the 2u plus 3's cancel on the last side, so you're just left with 1 times 2u minus 3. Distribute. Combine like terms. Subtract the 2u over, get 6u. Subtract the 22 over, get negative 25. Divide by 6, and u equals negative 25 over 6, which is perfectly acceptable as a solution since it is not negative 3/2 or positive 3/2. Okay, we did k in class, so let's look at j. I would pull a 2 out of the denominator here so that you notice that this actually has an LCD of 2 and 2x plus 3. We're going to multiply everything by that. Also, that means that x cannot equal negative 3/2 because you would subtract 3 and divide by 2 to figure that out. So for this first fraction, got ahead of myself while I was talking. Here's my LCD. Here's the fraction. Plus, here's my LCD. Here's the fraction. Leave it in factored form. It helps to see what cancels on the denominator. And here's my LCD. And here's the fraction, which is just a 5. So in this first one, the 2x plus 3's are gone. You get 2 times 2x, which would be 4x. This one, the whole denominator cancels, so that just leaves me with plus 6. Over here, you have a 10, 5 times 2, and you need to distribute that to 2x plus 3. So that would make that 20x plus 30. I would subtract 4x over and get 16x. Subtract 30 over and get negative 24. Divide negative 24 by 16. Those are both divisible by 8. That actually turns into negative 3/2. That is a solution that does not work. This is our restricted value. So that means we throw it all out and we say that this one actually has no solution. So if you ever get that restricted value as your solution after working, you don't have a solution to your equation. Okay, the last one in this piece is the L version. So this one has factors of 2x plus 5 and 2x minus 5 because it's perfect squares. We would multiply everything by those. So I'm just going to write it up here again. 2x plus 5, 2x minus 5, and 2x plus 5, 2x minus 5 for time's sake. The 2x plus 5's cancel in the first one. That just leaves you with a 2 and a 2x minus 5. 2x minus 5's gone, so that leaves you with a plus 3 and a 2x plus 5. On the other side, both pieces cancel, so you're just left with a numerator of 10x plus 5. So this is 4x minus 10 plus 6x plus 15 equals 10x plus 5. This is 10x plus 5 equals 10x plus 5. If you go to solve this, you get 0 equals 0 because everything is going to cancel out. This is what we call an identity. An identity is an equation where all real solutions work. So all real numbers or all real solutions work. Okay, and then the last piece is these literal equations. This just means you're solving for a different variable. So for example here, notice there's 3 c's in this equation. You want to get all the c's on the same side. So how about we subtract that pc over? Then we can pull that out as a GCF. So this would be c. You would have a d for the first term. C divided by itself would be a 1. And then you'd have a negative p left in the last term. Now that c is by itself, we can then divide this big parentheses back over. So it looks like n over d plus 1 minus p is what c is equal to. So you're still just solving an equation like normal. You just have to think you're just moving variables around to get the specific variable isolated. I will point out that WebAssign says if this is capitalized in the original, it must be capitalized in the answer. It is case sensitive. For B, we're trying to solve for A, but the problem is we have 2 of them and you can't cancel them because they're in different parts. This is a monomial and this is a binomial. So I would think of this as cross multiplication first. So B times 1 is B. B times negative A is negative A big B. And then that would be equal to A times 1, which is A. Get all the A's together on the same side. So A plus A big B. Do the same thing we just did. Pull the little a out to the front. as a GCF. So that would be little a, and then a divided by itself is a 1. Pull it out of the other term, it leaves behind the big B, and then we would divide the big parentheses back over. So B equals 1 plus big B, B over 1 plus big E, B equals A. Sorry, hard to say. For this next one, I would just think about cross multiplying again, since it's one fraction on each side. So that's R times I equals V times 1, so that's just V. If you want to solve for I, you just have to divide the R back over. So I equals V over R. I think we have just a couple more of these. If you're solving for R, notice there's only one R, so we should just isolate this. So I'm going to subtract the P over to the other side. And you can divide by more than one thing at a time. Because P and T both are connected to R by times, we can divide them both out at the same time. There's no adding or subtracting anywhere. So this is A minus P over PT equals little r. For the next one, we're supposed to get h by itself, but there's lots of h's, and some of them are in parentheses, so it's better to distribute that first. So the 2 goes to everything. Anything that does not have an h needs to go to the other side, so the 2LW needs to move over. Now I can pull the h out of that pair, and that would leave me with a 2W and a 2L. And then I can divide that over. So I would have S minus 2LW over 2W plus 2L equals little h. So again, this is just moving things around and getting something isolated. For this next one, might be good to do, I would do this FOIL first probably before just trying to do cross multiplication. So this would be Q plus P minus PQ. So there's actually 3 terms in the denominator. So when we go to multiply this, S is going to go to all 3 of them. So that would be SQ plus SP minus SPQ. And this side is just P times 1, so that's P. We're supposed to be solving for Q. So there's Q's on the left side, but this doesn't fit. So we're going to move that SP to the other side by subtracting it. We'll pull out the Q as a GCF now on the right side. And then we can divide by the parentheses to get Q by itself. So the top is to the numerator over here. The bottom is the part we divide over. So it looks very similar, but nothing cancels because these are not matching binomials. And then the very last one is a tricky one because these are all different variables because they have numbers on them. So if you want to get R2 by itself, you're going to have to use the LCD method. You can't do cross multiplication. So my LCD is actually each of those individual R's. So we're going to multiply that by each thing. So R, R1, R2, R3 times the first fraction plus, equals should still be in black. I'm trying to keep just the LCD part in red. Then I would have R, R1, R2, R3 times 1 over R1 plus R, R1, R2, R3 times 1 over R2. And then finally plus one more round of R, R1, R2, R3 times 1 over R3. Okay, in each case, one of the R's cancels out. So that leaves me with just, for this first one, R1, R2, R3 because it's times 1. In my second one, I would have R, R2, R3. In my third one, the R2s are gone, so this would just be R, R1, R3. And in my fourth one, the R3s are gone, so this is R, R1, R2. We want to find any of them that have an R2 in it because that's what we're solving for. So those need to all be on the same side together, and this guy needs to be on the other side. So I'm going to leave this as R1, R2, R3. Subtract the ones that need to move over. You have to take the whole thing. So minus R, R1, R2. That would be equal to the one that did not have the R2, because now I'm going to pull the R2 out as a GCF. So that would leave me with an R1, R3 minus an RR3 minus an RR1 equals all of this. And so my final answer, since I'm running out of room, I'm going to write it over here. You'd have R2 equals, this is the numerator because that was the part that was left over there, so R, R1, R3, all divided by R1, R3 minus RR3 minus RR1. Now that one is way harder than anything we would give you on the test. So I don't want you to freak out about that one. It's just, it's good practice because it makes you manipulate all these variables that look very much the same. And that is it for 2.1. To catch us up for